First of all, one member of the team go to the lake and gather some moistures of water in a bottle. Then we translate to the laboratory so we can make the test. In a bottle, we put the water in a 200 milliliters base. Then we made up the pH test when we introduced into the base a pH paper, and we compare with the color of the table, and it turned out to be the level 10.
Ah, mira. Entonces ya tienes que ver a qué color se parece. Mira, por ejemplo, ¿se parece al 9? No. ¿Al 8? Al 9 sí se parece bastante. ¿Al 9? Sí. ¿Al 8? ¿O al 7? ¿O al 6? No, al 6 no. ¿Al 7? Al 7.
Al 7, ¿no?
¿O al 8?
7 u 8.
Al 8.
Creo que era 8.
¿Al 9 está idéntico?
No, no.
Yo veo... ¿Sí? El rojo lo veo más hacia el 9 que hacia
No, yo
el
lo veo en
8.
8. A lo mejor se distorsionan los colores. No, no, no. ¿Es 8?
Bueno, es que yo veo el rojo lo veo más al 9, pero el azul lo veo más para el 8. Ah, bueno, ajá, sí, sí, sí. Yo diría que...
Then we put a sample of the water into the microscope to search for bacteria or microorganisms.
Oh. Oh.
Then we make the oil spill simulation where they give us 10 milliliters of petroleum. More specific, it's heavy oil with the API gravity of 20, and we introduce them to the water and let it sink for like a day. We watch with this that the density of the petroleum like float, even though it was the heavy one. But if we like move the base, the petroleums tend to stick to the glass, and that was like tougher or difficult to separate because the glass seems to be like very attached to the petroleum. The first system we made up was the distillation system. We thought that with that we can be able to evaporate water and then condensate it, and with that we can separate water from oil, which was like a hypothetical solution because it cannot be used in the river, but it can be used like in small scale. But it didn't work out well, or we think that it was like a problem from the lab because the fire like broke the glass and we have to change everything in case the petroleum starts to fall. The initial sample of water was clean, the oil free. Its color was yellowish green, it almost seemed fluorescent. Otherwise, water was odorless, and at least we couldn't detect any particular smell. The water pH was 8. This means that it was not 100% neutral, but a little alkaline. After letting the oil and water merge for little more than 24 hours and then trying to complete separate both substances, Through physical extraction and filtration, the three characteristics did change.
Pero sí. Va a salir filtrado, ¿no? ¿Sí? Sí se pegó aquí, ¿no? Se queda pegado ahí. Pues sí, algo que otro. Sí, no está yendo ninguna partícula de... Ah, no, sí, sí se rompió. Pero bueno, ustedes denle.
After putting the oil and then extracting them, the color was now light green, almost no yellow in it. It smelled a lot more like identical to gasoline. It was a very penetrating, acute smell, and it hurt. And its pH was reduced to 7, making the water neutral.
Sí.
Our team came to the conclusion that removing oil in real life solution is a painstaking task, and oil spills should not be taken lightly. On the lab, we removed some important components of the oil from the water, but in the ocean, where oil is usually leaked, removing is definitely not as straightforward as in the lab. Even on the lab, we could not remove all the components of the oil from the water. That is why it is very important to use all the previous knowledge about solubility, Lewis structures, bonds, polarity, and everything else that can be taken into consideration to find the most appropriate situation to the solution. Since it is well known, water and oil cannot mix up together thanks to its properties. It is important to search for a high-scale method that can take advantage of this and gather the 100% of the oil from the sea.